before we look at limits of trig functions, I'm just going to introduce you to some identities that we haven't used yet. These are called the double angle identities. Now we will use them more extensively and we will prove them next year. For the moment, I just want to make you aware of them so that you can use them when you are doing limits. Makes your life a little bit easier. So these are called our double angle identities. And again, like I said, we're just going to use them. We're not going to prove them at this point. So the one double angle identity is if I've got sine of 2 times an angle, I'm just going to call my angle A. That's equal to 2 sine of an angle times by cos of an angle. And again, I just want you to accept them for the moment because next year we do them in depth. Then if I've got cos of 2 times an angle, that's the same as cos squared of an angle minus sine squared of an angle. I can then also replace cos squared A with 1 minus sine squared A, and I land up with 2, other way around, I can replace sine squared A with 1 minus cos squared A, and I land up with 2 cos squared A minus 1. If I do what I was originally talking about, and I replace cos squared A with 1 minus sine squared A, I'll end up with 1 minus 2 sine squared A. So these are 3 different ways that I can rewrite cos 2A. So these are our double angle identities, which we are going to use in 1 or 2 of the examples, so just keep them at the back of your mind later when you are doing the exercise. Alright, so I've got some other results that are important. You looked at the proofs in previous videos and a Khan Academy video that I did include. So let's have a look at those very important limits. Okay, these are important limits. Alright, so the one that's very important is that when the limit as x tends towards 0 of sine x over x is 1. We can also flip that around, and the limit as x tends towards 0 of x over sine x is 1. Okay, then we've got the limit as x tends towards 0 of tan x over x is 1. And flip that around as well, the limit as x tends towards 0 of x over tan x is 1. So these are very important limits that we're going to use. What you need to be aware of is it's not necessarily just going to be an x. So you're going to have the limit, use my highlighter here, you're going to have the limit as x tends towards 0 of sine of something divided by that same something is going to give you 1. So I could have sine of 5x divided by 5x. I could have sine of a million z divided by a million z, provided then that z would be tending towards 0, would give me 1. Right, so let's have a look at 2 examples. They're relatively straightforward. I'll include a video that does talk about a bit more of a technical example. So let's have a look here at some examples. Okay. Alright, so if I've got, let's have a look at the limit as x tends towards 0 of sine 5x over x. That's my question. Now have a look, they don't match exactly because remember what I said when I highlighted? I said that that angle has to be the same as the denominator, exactly the same. So here I've got a 5x, but there I've got an x. That's okay. I'm allowed to manipulate it so that I get a 5x at the bottom. So what I'm going to do in red here is I'm going to times that x by 5. But I'm not allowed to just do that. unless I also times my numerator by 5, because that's exactly the same as timesing the whole thing by 5 over 5, which is 1. So I haven't changed it in any way at all. Now remember the laws of limits. That allows me to take this 5 over here, this constant. I'm allowed to take it out to the front. So I've got 5 limit as x tends towards 0 of sine 5x over 5x. Okay, so again, now I've got sine of something. Oopsie, let's undo that. Sine of something over the same something. That's exactly what I want. So the limit as x tends towards 0 of sine of 5x over 5x is just 1. So I've got 5 times 1, which gives me 5. Awesome. Let's have a look at another one. In this one, I'm going to look at the limit as x tends towards 0 of 2 sine 2x over 3x. Now again, in this case, if you have a look here, I've got sine of 2x and 3x. This is not so easy to just change. You can't just times it by 1. So let's just start our manipulation process. Firstly, I'm going to take my constant out. Now you see I've got 2 at the top and a 3 at the bottom, so I can take out a constant of 2 over 3. So I've got 2 over 3, limit as x tends towards 0 of sine 2x over x. Alright, now it looks a little bit more like the other one, except here I've got a 2x and an x, and I want a 2x there at the bottom. So I'm going to times the whole thing by 2 over 2. Okay, now I'm allowed to take this 2 out, so I take it out and I've got 2 over 3 times 2, which means I've actually got 4 over 3 limit as x tends towards 0 of sine 2x over 2x. Now again, I've got sine of something over the same something, which means the limit of that will be 1. So I've got 4 over 3 times 1, which is 4 over 3.